This episode of Fluid Power Forum is sponsored by IFP Motion Solutions Incorporated, the leader in engineering electronics into fluid power distribution. IFP spans the 13 central states from Minnesota to Texas. For more information, visit ifpusa.com.
I truly believe that this gives the engineers a lot of potential for future applications in ways of simplifying these applications and also having more control over them.
Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lenke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of our show, check us out on Twitter, follow us there. You can find us at the NFPA. And make sure to share those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. That is, in fact, one of the ways that we source topics for our show. If you see an interesting application of fluid power and you'd like to learn more about it, you can share it on social media with that hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. We're on Apple Podcasts, we're on Spotify, we're on a lot of the other podcatching services. Wherever you find us, go ahead and subscribe and then give us a quick rating. That really does help more and more of our friends in the industry hear about the show and join in on these important conversations. On today's show, our guest is Sandro Quintero. Sandro is a business driver for automation at Festo, a global manufacturer of process control and factory automation solutions. Sandro recently presented on the subject of smart pneumatics in packaging machine applications at one of NFPA's recent quarterly conferences. And so we invited him into our forum today to hear more about the content of that presentation and learn more about how smart pneumatics is reducing energy consumption in this key customer market. So Sandro, welcome to Fluid Power Forum.
Thank you for having me, Eric.
We're glad to have you on the show. I'm hoping that you can tell our listeners a little bit more about yourself and your background. How did you find your way into your current position at Festo?
Yes, of course. I'm a mechatronics engineer. That's the degree that I got in the bachelor's.
Mm-hmm.
And back then, when I was at the university, that's when I first saw the name Festo, because actually at my university we had this mechatronics lab, and one of the divisions within Festo is Festo Didactic. So back then, the name kept with me, and I kept going through my pursuing my degree and everything, and then as I was getting close to graduating, I started working for a machine builder, for a systems integrator, actually. And, there's where I started getting more into, machining and controls and all of that.
Sure.
And after spending a couple of years there, I was able to join Festo as a sales engineer.
Right.
This was approximately 11 years ago. Time flies.
Okay. I'm sorry, did you mention what university you graduated from?
I did not. Yeah, I graduated from a university in Mexico. It's called Universidad Autónoma de Ciudad Juárez.
Yeah.
It's right in the border with Texas.
And
that's where I pursued my bachelor's.
Well, that's
degree.
why I was asking, because I was surprised to hear that the university had a mechatronics program. I don't think that's common in the United States, at least. So that's interesting. That's an interesting pathway. And you learned about Festo there, you said.
Yes, yeah, we did. I did learn about Festo there. It's interesting that you mentioned that about the U.S. because I 100% agree. I was really surprised when I moved to the U.S. that I wasn't seeing a lot of mechatronics engineers, and luckily now, probably since the last 5 or 3 years ago, I started seeing more, programs opening up here and there.
Yeah.
But I still find it strange because, in Europe, in some countries in Central and South America, mechatronics is a very common degree.
Yeah, and I think in the United States, at least at the university level, we're still kind of separated into mechanical engineering or electrical engineering, right?
Correct.
And mechatronics is really the marriage between kind of areas of those two disciplines, if I understand it right. So
Exactly,
Yeah,
exactly. Yeah, it's a nice blend that you have there because you also throw in not only the electrical engineering but also a little bit of computer science, so you
right,
get into programming a little bit more.
right.
You also get fluid power. I did get some courses in fluid power, hydraulics, pneumatics, etc. So it's really good. I mean, usually when I'm talking to younger engineers or even students, I tell them, mechatronics is a really nice degree to have. The only challenge is that you know a little bit of everything, but you're not, the expert in anything
Yeah,
unless you pursue, further certifications or you specialize in something.
right.
But it's a really good degree to have if you're like, like if you manage teams with like multidisciplinary teams because you understand what each person is talking about.
Sure. Yeah, one thing I know for sure is that companies in our industry, I'm sure Festo is among them. They're really looking for that skill set, for people in to work in their organizations. Increasingly, it's not just a fluid power uh, discipline, if you will. It's a mechatronics discipline in a lot of ways. So that's
Yeah.
I'm sure Festo was happy to bring you on board when they had that opportunity.
Oh yes, yes. I was very lucky because I can honestly tell you that it was a perfect fit for me, and that's why I'm here.
Right.
11 years after, I'm still with the company, and I love it. I'm still in love with the company as the first time that I joined,
Well, can you
or the
tell?
first day.
That's
Yeah.
great. Yeah. Can you tell us a little bit more about Festo then as a company? I think people have heard the name before, but what products does it make? What markets is it in? Tell us a little bit more about Festo.
Yeah, definitely. So Festo was founded in 1925. It's a German company, and it started in the woodworking industry actually. And after some years, some of the owners actually got involved a little bit with pneumatics. So they started looking at the pneumatic technology,
Mm-hmm.
and they had this vision about, wow, pneumatics is really the future for many processes in different industries. So they started looking heavily into that, investing, and suddenly, Festo transitioned into being more of a pneumatics company,
Mm-hmm.
and that has been the case for decades. Um, the We get involved in multiple different industries, from automotive to medical, electronics, even mining. So it's pretty wide. The one thing that I really like about working at Festo is that I never get bored. Like you get to see different applications every day, talk to people in different industries every day, so you get to learn, how things are done in different industries.
Right.
Because believe it or not, although it's manufacturing and people will think, oh well, it's very similar, there are differences in each industry.
Yeah. Well, I know that. I mean, Festo makes a variety from a manufacturer's perspective. They make a variety of different pneumatic products. But a lot of the work, as I understand it, is building the systems and installing them on the different applications. You must have a tight relationship with the end market, with the customers, in order to determine what those needs are.
Yeah, at Festo we have a department that's called Customer Solutions,
Mm-hmm.
and basically this is a team of engineers that do that. They build these. I'm gonna call them subsystems. So if a machine has a subsystem, which is let's say a pick and place system, and whoever is integrating the system wants to get this pick and place system, they can get it from these Customer Solutions team within Festo, and they just get the subsystem and it works. Alternatively, they could also design their own and just buy the parts from Festo
Yeah.
instead of this subsystem. But it's a really good tool to have. You have both options.
So, in your experience, are you working mostly with industrial customers, automation type activities?
Yes, yes, definitely,
Okay.
definitely. 100% of the time is industrial customers.
Well, I know we want to talk about smart pneumatics, but I think before we get into those details, for our audience sake, why don't we just kind of talk a little bit about typical pneumatic applications in that industrial space? What are some of the benefits that those industrial customers would get from using pneumatics, and where would we find it?
The nice thing about pneumatics is that you can see it everywhere. I
Mm-hmm.
mean, if you walk into any manufacturing facility, from all of the different industries that I mentioned, automotive, medical, electronics, etc., you will see pneumatic applications. And I'm just going to mention one, for example. Imagine you have a conveyor and suddenly you need on a portion of the conveyor, you need a pushing system to maybe reject something.
Hmm.
There, it's an easy, an easy application where you will just have an actuator, moving back and forth or extending and retracting. And that will maybe push a box, out of the conveyor.
Right.
um, that will need the actuator itself, a valve that drives the actuator, service unit and sensors, and so on. And imagine this, talking about the same conveyor application, you might also have stoppers throughout the conveyor. A lot of
Sure.
times these stoppers are pneumatic as well. So there's definitely tons of applications out there. If we start talking about packaging, for example, you will see grippers, for example, on an end of arm tool on
Right.
a robot. You will have grippers. You will have suction cups with vacuum generators and so on. So pneumatics are literally everywhere.
And what are, I guess, I mean, I know the answer, but but why? I mean, what are the advantages? I mean, there must be other technologies that can perform some of those tasks. Why is pneumatics so ubiquitous in so many of these places?
Oh, yeah. So one of the reasons that I can think of is it's simple to use.
Mm,
It's very, very simple to use. And because it's a technology that has been around for so long, uh, not only the engineers that design the systems know about the technology, but also the technicians that are working in maintaining these systems, right?
right.
A lot of the people that acquire these machines or that buy these machines, of the end users, I mean, they also have to take care of who's going to handle this machine once it's working, the operators, the technicians, and so on. So they are very, very easy to troubleshoot. For example, is there air there or not?
Right.
What's the pressure? It's simple. The concepts are simple. Although I gotta say, like any technology, yes, of course, you do need some sort of training. You need to learn the basics of how compressed air works. You need to learn a little bit of physics as well. But if you compare it to other technologies, of course, it's simpler than, for example, electric automation, because electric automation, you need to know a little bit of maybe computer science too, like bits and bytes and whatnot. A lot of the times in pneumatics is, you apply 24 volts to a coil, that coil shifts a spool, and then you have air going from one port to the other, and that's about it.
Right.
So simplicity.
Yeah, that's one of the real advantages of that technology, and that's probably why it's so widely used. You mentioned when you walk into an industrial setting, you often see pneumatics everywhere, but you also hear it everywhere. You can hear the hissing of the air as the actuators are powered each time. So
Exactly.
yeah, well, that's great. Well, I know that I mentioned at the top that you had recently presented at one of our quarterly conferences, and your topic was on something called smart pneumatics. So let's talk a little bit about that. What you did a good job describing kind of a more traditional pneumatic system. What's smart pneumatics? What's different about that?
Yeah, so that's a great topic, and one topic that I enjoy a lot. So what we did with pneumatics is, as I mentioned, Festo has been working on this technology, pneumatics, for years, right?
Hmm.
For decades. We are constantly challenging ourselves. We're constantly challenging our R&D department and saying, let's think outside of the box. And I'm gonna do a like a segue here just a little bit, but I'm gonna come back to this topic.
Sure.
I don't know if you have ever heard about the Festo Bionics. Have you?
Oh, are those the animatronic animals that I see at
Yeah.
trade shows all over the world?
Yes, 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 yes.
Yes, those are
So
great. Yeah.
anyone listening, if you haven't heard about this, you can just look them up on YouTube, and they're called Festo Bionics. Why am I bringing them into the conversation? Is because these kind of projects, a lot of the times I get asked from customers or users in the industry, why is Festo doing this? Like, are you guys going to shift your industry, or are you going into entertainment now, or what?
Right.
And my answer is very simple. No, this is inspiring. This is what we do. And I can't say on our free time because we don't really have a lot of free time. Everyone's busy, right?
Yeah.
But the management at Festo says, and the owners, they say, let's think outside of the box. And, we're all engineers, we're creative. But the problem is that if you're always looking at the same time of applications, industrial applications where, like I mentioned, a conveyor system, I guess your creativity starts getting stagnated in a way, right? So what they did is they started, looking outside and let's see how nature does this. How does a chameleon, for example, grip something with their tongue or captures a prey with their tongue?
Hmm.
And with this, we start thinking outside of the box. And now I promised that I was going to come back to the original question. By doing this, with these kind of projects, we started thinking outside of the box and challenging ourselves and saying, why why is pneumatics the way it is, and what can we do to add additional functionality to it, that would be able to simplify even further some applications that maybe in the past we were not able to do, or maybe we were able to do, but it was just too complex,
Hmm.
too many components. And that's how we came up with smart pneumatics. Now, what is smart pneumatics? Basically, what we did is we added intelligence to some of the valves that we used in the past.
Right.
And when I say intelligence is, instead of using a discrete valve where you have a coil, you turn it off or you turn it on, what we did is we started using piezo valves. And with
Ah,
piezo valves, now we have analog control. So instead of open or close, now we can say, I want the valve to be 20% open, 23.5% open, 40% open.
yeah.
So now we have more control over a valve.
And that, I'm going to assume that that translates also among many things, but that translates into positioning of the cylinder, right? I mean,
Yes,
yeah,
correct.
I think a lot of people have this impression of pneumatics, which is not, which is based in fact about on or off, right? Bang, bang, right? That's how they sometimes think of it, right? In terms of what pneumatics can do. But what you're describing is more of a variable positioning of a pneumatic cylinder, if I'm hearing that right.
Yes, yes.
Yeah.
And not only that, the first time that I saw this technology, when I got involved into this technology with the developers, I was really, really surprised because my mind, my engineering mind started racing. And I was like, oh man, if I only had this technology, 5 years ago when I had this project or these other project, I
Right.
could have simplified things way more, right?
Right.
But to your point about positioning, not only positioning, but think about controlling the speed of an actuator.
Oh, sure. Right.
Right now, when we want to control the speed of an actuator, we have to go to the flow controls. We assign a setting, and that's it, right? With this technology, we can change the speed of the actuator on the fly, and I'm talking about a pneumatic actuator.
Right. And that would be changing it through a digital interface of some kind, right? Not, through a computer, essentially.
Exactly.
Yeah.
So there is a microcontroller embedded on the valve manifold, or also on the valve, individual valve, and this microcontroller interfaces with whatever control system the user has. Like a PLC or a PC. That's possible. Yes, of course.
Yeah. So, Sandra, I'm wondering if you can help our listeners understand, like you mentioned, that this opens up new kinds of applications. Like, what are some of the areas that this technology can get applied to that more traditional pneumatics would not be a player in? Like, what are the new things that are happening?
For example, for instance, one of the applications that we have worked on in the past is, for example, gripping a certain element, a certain product that needed a certain force. Certain force applied to the product, but that you could say that's easy, right? Like you could control that with even standard pneumatics. But now with the trends that we have in production, where you not only have product A, you could also have product A, B, C, D, E, F, and G, right? Like multiple different products.
Mm-hmm.
Now that means that maybe you need different forces. And yeah, in the past, you could run product A for one shift and then change the second shift to product B. But now we have a lot of mix, right? Like we have a lot of end users that want to run product A, B, and C on first shift, and then D, A, and C on the second shift.
Sure.
So that requires adaptability from the machines. Um, in the past, what you would have to do is you will have to have these changeovers, right? Like you will have to, have some downtime and then have the technicians adjust the machine for the next product that you're going to run. Well, with smart pneumatics, you can just run recipes, and then you can say, we're going to run product A at this moment, and then in the next 5 seconds, we're going to run product B. and the machine automatically adapts because that's written in the program of
Sure.
the machine.
Yeah.
Um, in the past, this was really, really difficult. I mean, you could, as I mentioned at the beginning, you could do it with standard pneumatics, but you would need like, I don't know, 40 different components, to
Right.
do this. And now you only need, one.
Because it's all controlled. The same components are being applied in different capacities, essentially.
Exactly,
Yeah.
exactly. So the first couple of meetings, I recall clearly the first couple of customer meetings that I had about this technology. When I talked about it, I could see the engineers, kind of like quiet, but I could see in their eyes
Yeah.
that they were thinking, "Huh,
Yeah.
now
They
I
were
could do this."
they were soaking it
So
in. They were soaking
yeah,
it in. They were trying to figure out, oh,
yes.
okay, this is a new way of doing things, right? Yeah.
Yes, yes.
Well,
And I'm not gonna say that the first time that you hear about this technology, you're gonna be like, oh yes, I need it now, I need it tomorrow. What I'm gonna say is that this is one of those things that you add into your toolbox, and now you're like, I'm probably gonna need this in the near future.
yeah. That's great. So, Sandro, we've reached the point in our show where we need to take just a quick break to let our listeners hear about some other opportunities in the fluid power industry. But we'll be right back after this short break. I'd like to tell you about a series of quarterly conferences NFPA conducts with the Fluid Power Industrial Consortium. That consortium is an industry networking group established by the Milwaukee School of Engineering, and with them, NFPA offers this quarterly series of conferences on the latest fluid power technology advancements with immediate implementation. These conferences are open to everyone. The consortium helps bring a broad group of stakeholders to these events: fluid power suppliers, component manufacturers, distributors, and OEMs all come together to hear and discuss presentations on the market-ready technologies that are affecting their businesses. Fluid power technology advancements is just one example of the topics that get much deeper coverage at these conferences. If you like what you hear on Fluid Power Forum, you're going to love what happens at these events. For a full schedule of quarterly conferences and topics, head to nfpa.com and click on the Events tab. They are truly a way to bring this wide and diverse industry together for education and networking. Okay, we're back from the break, and I'm speaking with Sandro Quintero of Festo, and we were talking about smart pneumatics, and the exciting changes that engineers are using that technology in the industrial applications. And I was about to ask you, if you could talk a little bit more, Sandro, about kind of the how does this work side of it. So there must be a sensors embedded in these products somewhere to do all this controls. Is that an important piece of the formula here?
Yes, yes, it is an important piece that runs in the back end.
Mm-hmm.
Usually, whenever I show this technology to someone that's interested in looking at it, and like your listeners right now, they're like wondering, okay, but how does it work?
Yeah.
Yes, there are some sensors. We have some temperature and pressure sensors embedded into the valves. They are internal. A lot of the times when I bring this up, I sense that users are concerned because they're like, oh my God, so does that mean that now I have to have an analog input on my PLC, or I need to have further processing of these sensor data?
Mm-hmm.
And they are always really glad to hear when I tell them no. All of this happens on the back end. We
Right.
have a microprocessor embedded in the valve that takes care of all of these data. So you don't have to do anything with these sensors. These sensors will basically just give you some feedback at one point, but all of this feedback is conveyed through field bus. For example,
Okay.
Ethernet IP or Profinet or EtherCAT, some of these field buses that are in the machines. Now, how does it work? Basically, the way it works is that we have an array of piezo valves internally on each of the valves. So picture four piezo valves, and for people that recall the Wheatstone bridge technology, it's a very similar approach where we have these four piezo valves in such an array, And with those four piezo valves, if you're not familiar with piezo technology, it's basically a piece of ceramic that, depending on how much voltage you apply to that piece of ceramic, it'll bend.
Right.
And while it bends, what we do internally in the valve is that we open or close a port. Now, I mentioned that we have four of these piezo valves. With the combination of these four valves, we are able to supply or exhaust the compressed air. And this happens automatically via some algorithms that we have running on the valve itself.
Right.
So again, I just want to be very clear. If you wanted to use this technology and you wanted to extend an actuator with a certain speed, you don't have to worry about the interaction of these four piezo valves, and you don't have to worry about the temperature and pressure sensor and all of that. The only thing that you have to do is on the interface, you have to say extend at 30% of the speed, and then it'll go.
And
So it's pretty simple to use.
yeah, well, I appreciate that more detailed description. It's fascinating to hear, the inner workings. That sounds pretty novel to me in terms of four, if I heard you right, four different piezo valves that can open and close fully or partially in probably thousands of different combinations, I'm going to imagine. And that is really what's going to control the amount of air that flows through the system. Did I understand that right?
Yes,
Okay.
that's in a nutshell how it works.
But as you just said, as the operator, you don't have to navigate that complexity. You just say, I want 30% pressure or whatever it would be. And the system then knows what the right configuration of all those valves should be in order to deliver that flow.
Exactly,
Right.
exactly. It can be overwhelming, and that's why only if the person asks for details, I go into the details. But if they don't ask about the details, I just show them.
That's
What do you
great.
want to do? You want 30% of the pressure? How much flow do you want? You want 50 liters per minute, and then I show them the interface. But
Right.
your listeners are technical people. A lot of them are engineers, and we as engineers, we're always curious. We
Yeah.
always want to open things up and see how they work. So I don't mind answering that question.
That's great. Well, I'm going to assume that strategy results in energy savings because you're using just the right amount for the application each time, right? And as you said when we talked previously, that can change, shift by shift or minute by minute, probably. So, is that true? Are we seeing energy savings as a result of this technology?
Oh yes, yes,
Yeah.
yes, yes, definitely. And a lot of the users, the end users, they have initiatives, corporate initiatives saying, hey, we need to start saving up, saving on the energy consumption that we have at our plants. All of the companies out there are becoming more, environmentally conscious. And this is a quick win actually, because
Yeah.
a lot of the times we all know, pneumatics has been around for decades, and if you think about it, like for example, when you move a certain load, let's say that you're moving a 3 kilogram load, a lot of the times what I see is an actuator moving at 90 psi, for example. And if you calculate what the 90 psi, what force that actuator gives you at 90 psi, what I find is that I'm just going to throw out a number, but 90 to 95% of the time is you're using extra pressure that you
Hmm.
don't really need. You
Right.
probably just needed like 40 psi, right?
Right.
But why are we doing that, and why have we done it for so long? Well, it is because we have a central air supply unit, and maybe we just set it to 90 psi and just let it go,
Right.
right? Or let it run. But with this kind of technology, now, as you mentioned, now you can control that and say, you know what, on application one, we just need, or line one, we just need X amount for, the 3 kilograms. But on the other one, we're moving 20 kilograms, so maybe we do need more pressure. Um, Added to that, and I'm really glad that you brought up that topic about, energy consumption. We do have another algorithm, another program that runs within this smart pneumatics solution that will tell you when there are leaks in the system.
Mm.
Um, this is very fascinating because a lot of the times when I talk to customers and I tell them, hey, if you hear that hissing sound when the machine is stopped, that means that you're losing power, you're losing compressed air right
Right.
there, right?
Right.
So with this algorithm, what you can do is you can run it in between shifts, and then it'll tell you, you're exceeding the threshold that you told me for this actuator. Maybe it's now time to replace it or do some maintenance on it.
That's fascinating as well. So, I mean, I know the painful reality in a lot of industrial plants is when the leaks occur, they just turn the pressure up. So,
Exactly.
right, they just they don't fix the leak, they just get more air going so that it kind of overpowers the leak, if you know what I mean. Then the machine keeps running then as a result. So that's even more wasted energy as a
Yeah.
result. So your system will help them not just save energy in its operation, but help them find those leaks, it sounds like.
But not only save energy, Eric, if you think about it, because think about this manual adjustment that you just mentioned,
Yeah,
right? This is very empirical, right? Someone is just going in there and just dialing up the pressure regulator, but without having exactly the data, And the reason why I'm mentioning this is, what if this additional pressure starts giving you some quality issues on the final product?
right,
Maybe you're pressing something into place and now you're exceeding the force that this product needed, right?
right.
So this is another thing to consider, and this helps as well. Having control over these kind of variables or these factors, parameters, gives you also more certainty on in terms of quality.
It sounds like another application or another benefit of this would be, what they're calling now predictive or preventative maintenance, that it would give you the ability to know when parts need to be replaced. Am I interpreting that right as well?
You
Yeah,
are for sure. And what this will tell you is exactly that. It'll raise a flag for you, and it'll say, hey, there's an issue here. Yes, of course, it's up to you if you want to fix the issue. It's like the check engine light on your car. Like
right,
I've seen many people, have the check engine light for months and they don't do it. They don't do anything about it. But that's probably there's a problem there. So in the industrial environment, luckily, we do have processes in place for maintenance, continuous maintenance and so on. So this helps for sure, because if you don't know that there's an issue, you're never going to address it. So
right.
this helps.
So I'm kind of curious, again, from the operator's point of view or from the plant manager's point of view, like can you describe the interface that they're looking at? This is a computer monitor, or how are they accessing all this information?
Yeah. So there's two ways. One
Yeah,
way I'm gonna say is for monitoring and maybe commissioning, and that it's pretty easy to do. What you do is there's an RJ45 or an Ethernet connection on the valve that you just plug in an Ethernet cable there, and you plug the other end into your PC, and then you can open any web browser like Google Chrome or Microsoft Edge or any of this. You put the IP address for the valve manifold there, and then you will have in the web browser you will have a nice interface, very easy, very intuitive to read, and with this interface you can monitor faults. You can even test movements, if you wanted to advance or retract an actuator. Of course, if you're going to manipulate some of these other things, it requires a password, because you don't want anyone going there and changing things.
sure.
But yeah, it's as easy as that. Plug in your PC, web browser, and that's it. Now, I mentioned that's mainly for monitoring and commissioning,
Yeah,
because at one point you want this valve manifold to work autonomously with being controlled by a PLC or a PC or something, some sort of controller. And for that, you can use another Ethernet connection that we have on the valve manifold, and just plug that into your PC, into your PLC, and then you will see all of the data available on your PLC. For the programmers, this a lot of times when you mention this, they are immediately thinking about bits and bytes and data, and they're like, oh my god, this is going to be a nightmare.
right.
No, what we did is we also wrote some function blocks. So it's basically interfaces for the programmer that they can use to easily program this device.
Okay. Yeah, so it sounds like this is something that can not only just be part of new applications, but it can be retrofitted onto existing applications quite easily.
Yes, yes, and we actually we have some applications running right now with machines that were probably, I'm gonna dare to say that probably 20 to 15 years old, machines that we retrofitted.
Yeah.
In conjunction with a machine builder, we helped them out, and these machines are working now with additional functionality. And that's pretty nice because a lot of the times these machines, they're multi-million-dollar machines, and you don't just wanna you don't wanna just scrap them, right? Like you wanna
Of course.
keep getting some production out of them.
Well, yeah, I mean the machines that are operating, I think in the world's industrial plants have age on them. They're
Yeah,
as you said, they're major investments. They don't. It's not like an iPhone. You're not getting a new one every single year, right? So,
exactly.
and so this is an opportunity to develop greater productivity as a result. Just to put not too fine a point on it, right? So,
Exactly.
yeah. So, I mean, can you give us a sense of, the how new is this technology for Festo? Is this something you've just recently introduced into the market, or you've been doing this for a while?
No, I wouldn't say it's been out for so long.
Okay.
It's probably been out for I would say openly out for the last 4 or so years. Um, we started looking into this technology more than like many years before that. But as you can imagine, this took a lot of time for us
Yeah.
to, come up with a working concept. After we came up with this concept, we have some pilot customers that we work with. So they can give us some feedback. What do they think? What they like? What is it that they didn't like, and so on.
Yeah.
But yeah, I would say probably between 4 to 5 years.
Well, that's where I was actually going next. I'm curious, like, kind of what the reaction from the customers have been. What is there a particular markets that this works best in, or at least has had most exposure to, and what kind of feedback are you hearing from the customers?
I would say the most common market is probably packaging because they see a lot of product variation,
Uh
right?
huh.
So packaging is a really, really good fit for these kind of technology. I wouldn't say that's the only industry because we also have a lot of applications in the electronics industry where they have to have like quick setups as well. Even in the semiconductor industry, we have some systems working there. Packaging, I would say, is the number one. Eric.
Yeah, I know you talked about that in your presentation that we've mentioned several times now as well. So,
Exactly.
how do you see this smart pneumatic technology continuing to impact the future of packaging equipment?
I actually think that we're gonna see it way more in the future. As you can imagine, there's a curve for adopting a new technology, and especially in the industrial environment, because as you mentioned, it's not like, oh, a new thing came out, I'm just gonna scrap what I have and use the latest and greatest thing. It takes some time, but I truly, truly believe that this gives the engineers a lot of potential for future applications in ways of simplifying these applications and also having more control over them. Now, we also have to pair that with where are we going in the consumer market. We're not going into just wearing or just using one kind of product in our households. We're using multiple brands, multiple colors, multiple things. So I do expect that the product variation is going to continue, and this is going to require manufacturers to keep adapting and making their machines more adaptable.
Yeah, it sounds like it's a still a fertile area for development. Do you have any product innovations that you guys are working on that you can share at this time? What's the next stage for this technology?
Oh boy, we constantly have things cooking. I wish I could. I get a lot of anxiety when people ask me about this because I really want to tell them what we're working on, but unfortunately we have to wait. I can assure you that we are gonna have some really, really cool technology coming out in the next months and years. We're constantly working on new technology, and this smart pneumatics is a proof of that. I would definitely encourage anyone listening in to go have a look at the literature, go have a look at on YouTube. There's some videos as well, and you'll get an idea. But yeah,
I
that's
get,
the overall
I get,
message.
yeah, that's fair. And I guess what we should do is we should check out whatever the latest Festo Bionic is and see if we can interpret where the where the innovation is going as a result of that.
That's a good point, Eric. I like that one. Yeah, because if you get an idea of what we're doing, you're probably gonna say, "Oh, well, these guys might be developing this other thing." Yeah,
Try to
for sure.
connect some of those dots. Well, maybe when you're ready to roll out the new version, we'll have you back on the podcast and we can talk more about more innovation going on in the space. It's certainly been good talking with you, and it's been an exciting topic.
Thank you for the time, and definitely, I will love to come back and bring additional and new technology, exciting technology into your show.
Right? Thanks, Sandro. And that is going to wrap things up for this episode of Fluid Power Forum. My thanks to Sandro Quintero, who has been my guest. If you'd like to connect with him, he tells me the best way to do that is to check him out on LinkedIn. And we'll be sure to put a link to his LinkedIn profile in the show notes for this episode, so you can find that easily. Also, if you're looking for more fluid power content, like what Sandro has shared on this episode, you should be checking out those quarterly conferences we've mentioned a few times. You can learn more about our upcoming conferences by visiting our hub on the web. That's nfpahub.com. If you're a member of NFPA, you can actually download Sandro's presentation and get even more information about this exciting technology. Also, to hear the latest fluid power technology and learn from industry experts, we ask that you make your plans now to attend IFPI, the International Fluid Power Exposition. Our next show will be March 14th through the 18th in 2023 in Las Vegas, Nevada. For more information, you can go to ifpe.com. Fluid Power Forum is a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, and I want to remind you to join us next time in the forum.